Hello everyone, my name is Senti, and welcome to a tutorial series on Stormworks Lua. This episode is primarily focused on beginners to Lua and programming in general, but it can also be a good refresher for experienced programmers as well. For any experienced programmers watching this series heavily prioritizes readable code over clean and efficient code. The YouTube playbar is broken up into sections to help navigate, and with that, let's get started learning Stormworks Lua. Notice how I said Stormworks Lua and not regular Lua. There is an important distinction between Stormworks Lua and regular Lua, and I will denote this by saying either Stormworks Lua or regular Lua. But real quick, what is Lua? Well, it's the Portuguese word for moon. It's also a programming language developed in the mid-1990s and is often embedded, put inside of video games such as Roblox, BeamNG Drive, Garry's Mod, Stormworks, and World of Warcraft. It can also be used to make entire games such as Teardown, and is often used in industrial applications such as with Adobe Photoshop and Adobe Lightroom. Lua is incredibly easy to learn, with only 21 reserved words that we'll start to get into over the next couple episodes. In Stormworks, we use Lua primarily for drawing on the in-game screens and for doing math. We can use Lua in Stormworks by placing a Lua block in the microcontroller editor. We can see that there are 4 nodes: composite input, composite output, video input, and video output. The composite input is used to put data into our script, such as our speed. The composite output is used to output data from the script, like if our script has some math in it. The video input can be used to chain together multiple Lua scripts, or more commonly, to have Lua overlay on a camera feed. The video output connects to a monitor, or to other Lua scripts. Inside the Lua script, we will see that there are 2 chunks of code, but we'll get into that a little bit later. First, let's learn a little bit about the language itself. The most important part of any programming language is variables. What is a variable, you may be asking? A variable is exactly what it sounds like, something that varies. It's a data point. Now, what does a variable look like in Lua? It looks like this: name equals value. This value can be any one of 5 primary data types, but only 3 of these data types are important to us right now. The simple data type to understand is a Boolean. A Boolean, or bool, is true or false, 1 or 0, on or off. We can write this by setting the value to either true or false. Another of the 3 data types we will focus on today is a string. A string is a collection of letters, numbers, and symbols. A string in Lua can be created by setting the value to something like this: a string of characters surrounded by either single or double quotes. The final data type we will focus on today are numbers. We all know what numbers are, I don't need to go over them. For those asking if Lua uses integers, floats, doubles, or whatnot, Lua uses floats everywhere. We can compare variables using expressions, and manipulate using operators. Lua supports the 6 basic arithmetic operators: addition, subtraction, multiplication, division, exponentation, and modulo. We will explain modulo in episode 2. We can compare numbers using the relational operators: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Booleans can be compared equal to, but there is also some Boolean algebra allowed: and, or, and not. And will be true if the bools on both sides of the word are true, or will be true if either side or both sides are true. And not will give the opposite of whatever is on the right side of it. We can compare strings using equal to and not equal to. We can put 2 strings together not by conventional adding, but rather by concatenating, which is a fancy word for combine. We use ... to concatenate in Lua. We can also concatenate strings to a number. The final expression we will talk about is the length operator, a very, very useful operator in Lua to get the size of something, such as a string. If we stick a hashtag, $, number sign, whatever you want to call it, if we stick this in front of a string, we will be able to get the length of it. For example, the length of hello is 5, since we can see there are 5 characters between the quotes. Very useful. Lua uses the general order of operations we all learned in elementary school, PEMDAS or BODMAS, whatever you call it, just with the other fun stuff stuck on top. We can see the parentheses always go first, so you can modify an equation's order of operations by using them. When in doubt, always use parentheses. The single most useful part of Lua we will explore today is the if statement. The if statement lets us check something, anything, and then run code if that something was correct or not. If statements in Lua follow the simple syntax of if condition then, where the condition is what we want to check. For example, if x is greater than 0 then will be true if and only if x, whatever number it may be, is greater than 0. And if x is greater than 0, then this code block will run. We always finish an if statement by putting an end at the end of it. We can check for additional conditions using the or and keywords as mentioned earlier. Here, this code will only run if speed and altitude are greater than 5. We can also easily run a different bit of code if neither of these conditions are true using the else keyword. Here, we can use the else keyword to run other code if x is not greater than 0. These two code blocks run exactly the same. We can also check for different cases using the else if keyword. For example here, we can check if our altitude is above or below 0, and run different code based on it. And finally, we can combine all three to check if our altitude is above 1000, above 100, or below 100, and run 3 different code blocks based on it. Again, you'll be using this a lot. In Stormworks, we have a basic input and output, or I/O, system that I hinted at earlier with the composite in and out. In Stormworks, we use this bit of code to get whatever number is on channel 1 of the input composite signal, which in this case is from a seat, and set it to a variable called ws_axis. The ws axis from a seat is on composite channel 2, so that is why there is a number between the parentheses. This is called a function call, which we'll get into more in episode 3. We can also input booleans using input.getBool instead of .getNumber, as shown here. This will get hotkey 1 on the seat, which is on composite channel 1, and set it to a variable called hotkey_1. Output works much the same way, as shown here. We can output numbers and bools, nothing else. So now, let's open up the microcontroller editor and create a super simple Lua script using everything we've just learned over the last 8 minutes. And here's our test stand. I've set up a light, a throttle lever to emulate our altitude, and I've just placed the default 2x2 basic microcontroller that's completely empty. What we'll be able to do with this setup is create a super simple microcontroller that'll turn on this light if our simulated altitude is greater than 10. To make sure that our simulated altitude, the throttle lever, can get higher than 10, I'm going to set the max value here to just something that's above 10. 100 should do. Now, I'm going to go ahead and I'm going to edit the microcontroller. Normally you'd want to press the microcontroller editor here at the top of the editor to actually create a microcontroller, but since I've already placed mine, I'm just going to click the edit button. Here's the basic microcontroller editor, again blank as I said earlier. What I'm going to do is I'm just going to name our microcontroller Alt Checker and reduce the width to 1, since we only need 2 nodes. I'll go ahead and add 2 nodes. I'll call this light and make it an on-off output so we can actually turn on our light. And I'll call this altitude and make it a number input so that we can input our altitude. Now into the logic tab here, I'll separate these two, and I'll place down a Lua script, and we'll connect them up. But I can't actually connect our altitude or our light to the Lua script, so what gives? To fix this, we're going to need to place a composite read so we can actually connect it. And I'll leave this at its default settings. You'll see why once we get into writing our script. And on this side, I'm going to place composite right number. I always lose those positions. And I'll just go ahead and hook it up, also leaving this at its default settings. And now we can actually go into the Lua script and click the edit script button. We'll see that there's our default code that I talked a little bit about earlier. We don't actually need anything in the on draw section here for today, so I'll just delete that entirely. That's used for writing on monitors. And I'll also go ahead and delete this onTick section as well, but not the actual name. We're going to want to keep that. The first thing we're going to want to do is we're going to input our altitude from the composite signal that's coming in. To do this, we'll just write altitude equals input to get number 1. The reason that it's a 1 is because that our start channel here is set to 1. If you were to connect a second number to this, and also want to input it through a similar line to this, you're going to want to make sure to set the 1 here to a 2 instead. And as we can see, this looks just like our name equals value from earlier talking about variables. And now, we're going to want to use an if statement to check if our altitude is indeed greater than 10, and do stuff if it is or isn't. If statement, again, if condition then, so if, and our condition is our altitude is greater than 10, then. And if it is, output .set bool 1 true. The true here shows that we're going to output a true signal onto channel 1. The reason we're doing channel 1 is because the composite read is set to channel 1. Else, if our altitude is not greater than 10, if it's less than or in fact equal to 10, then we're going to want to do the opposite. We're going to want to set a false signal to channel 1. Again, output.set bool 1 false. The false here to turn off our light, and the 1, again, because the composite read is set to channel 1. And to finish off the if statement, we'll just put an N there. That's actually all we need to write. I'll make sure I didn't make any errors by using the check errors button here. No errors detected. That's good, I guess. And here, we have our entire microcontroller. Super simple. I'll click update. If you just created a microcontroller, you're going to want to click save instead and use your inventory to search and place it. Using the logic tool here, I'll connect up our throttle lever and our light. Looks like I switched the positions around a little. Oops. And spawn it in. We'll go ahead and check. Does it work? Hey, it looks like it works. If our altitude is indeed greater than 10, the light turns on. Oh, isn't that cool? And look at that. A super simple microcontroller that turns on a light if our altitude's greater than 10. And that is episode 1 on this 5-part series of Lua Basics. Today, we reviewed what Lua is, how to use it in Stormworks, and Lua Basics, such as variables, expressions, if statements, and I/O. In the next episode, we will get into touch and drawing on the screen. To make sure that happens, I would appreciate some feedback on how to improve, if I can. My name was Senti. I'll see you next time.